Hey guys, Mr. Riz here to help you out with the start of the 2.5 note. So what we're going to look at is what's known as implicit differentiation. Basically, that means we're going to take the derivative, but we're going to use what's known as implicit form. So what we've used before was always explicit form. Explicit form is when we have a variable already by itself. So an example, if we had like y equals 3x squared minus 5, the y variable is a function of x because the y is already by itself. The x works with it and develops or change what y is. Implicit form is when we have two variables that are on the same side together. They work together. So like x, y is an implicit form. You can see like we can take an implicit form and turn it into explicit form and take the derivative. But what we're going to do now is like, what if we have equations that are just more than just an x is a function of y, or actually y is a function of x. So an example would be like something if we had an equation like x squared minus 3y squared plus 4y plus 2. It'd be very difficult to get a single y by itself. In fact, I'm not even sure it's really possible to get a y by itself since we have a y cubed and a y. But just because we can't get it by itself doesn't mean we can't take the derivative of it. So when we take the derivative of an equation, we are actually doing something that we don't normally see. What we are doing is showing that when we take a derivative, which is d over dx, which is the rate of change of x. You know what, I might get my pen here to write this part down. Un momento. So when we take a derivative, like if I have a normal equation here, I say like y equals 3x plus 2. What we do is we say, okay, let's take the derivative. We're saying let's take d dx of y and take d dx of 3x plus 2. So what d dx means is we're finding the rate of change, but we're finding it with respect to x. So technically, when we do dy dx, we would get our d dx of y, we get dy dx, which we've learned just to say that is called y prime. That's called the derivative. And then on the other side here, we'd say, okay, this would be a 3 because the derivative of 3x is 3 and the derivative 2 goes away. Now, technically what we do is we take the derivative of 3x, which is 3, and we say we took the derivative of the x with respect to x. And then we took the derivative of 2, which is 0, which has 0 x's of dx over dx. So whenever we take the derivative, technically what we do, we put the variable that we took the derivative of and what we took it with respect to. Now dx over dx just cancels out to be 1, and so that's why the derivative goes down to 3. So that was the really kind of complicated version of what we're going to do, but implicit derivatives are actually pretty easy. What we're going to do is we're going to take the derivative with respect to a variable. If the variable matches, we do what we just normally do. If it doesn't match, we're going to put a d something over d something. Typically, we're going to start out with like dy dx and moving on. Okay, so let's jump into a couple examples here. Oh, just to show you here too, in the power rule here. So if the variables match, we don't need to put the dx over dx, but if it doesn't match, we need to include a dy dx. So you can see this one here, x plus 3y. The derivative of x is 1. It matched, so we didn't need to put anything extra on it. 3y, the derivative of 3y is 3, but it didn't match. It wasn't with respect to x, so we put a dy dx. So maybe let's do another problem here just to show you guys another example here. So if I was going to do, what is the derivative of x squared plus 4y cubed equals 5? And we're going to do d dx of this whole thing. All right, so let's take the derivative of x squared. The derivative of x squared is 2x. And it matched the bottom here, matched the derivative with respect to, so we don't need to put anything special. All right, what about the derivative of 4y cubed? That would be 12y squared. But does the y match with the x? No, it doesn't. So we're going to put a dy dx here at the end. And then what's the derivative of 5 is 0. Technically, we could put a d something over dx, but 0 times anything is just 0. So there we go. Okay, so let's go through this problem here. How do we take the derivative of x times y squared? Well, since it is two things separately, technically we need to do the product rule. So let's take the derivative of x. The derivative of x is 1. It matched if we were going to take it over d dx with respect to x. It matches, so we're going to leave the y squared alone. So 1 times y squared. And then plus. Now we'll leave the x alone. We'll take the derivative of y squared, which is 2y. And then we need to remember here we took it with respect to x, so we need to put a dy dx. All right, and so this simplifies down to, well, this would be y squared plus 2xy dy dx. We're going to use dy dx. You might see it known as y prime because they are the same thing, but dy dx will help us out in the next section. So when it comes to basic rules with implicit differentiation is, we're going to differentiate both sides with respect to x. And tomorrow we'll learn about, different things with respect to t or respect to something else, but we're going to do that. Then we're going to collect any term that has a dy dx, put it on the left side. Anything that doesn't, we'll put the right side. We'll factor out that dy dx, and then we'll divide to solve for it. So we'll go through these two problems here, and we got a couple more. And we'll just make sure we get the practice of this here. So if we got y cubed plus y squared minus 5y minus x cubed equals -4, we're going to take the derivative with respect to x. So anything that isn't an x needs a dy dx at the end, or whatever it is. So y cubed would be 3y squared dy dx. All right, then moving on, plus y squared becomes 2y dy dx. 5y becomes -5 dy dx. All right, negative x squared just becomes -2x. We don't need to put anything there because it matched. And then equals, the derivative of 4 is 0. We can't forget about that. So if we look here, this has a dy dx, that has a dy dx, that has, and that doesn't. So we're going to move it over here. So we get a 3y squared dy dx plus 2y dy dx minus 5 dy dx. And you'll do so many problems after this that this steps will shorten up quite a bit. Equals, we'll move that over to x. Okay, now everything on this side, they all have a dy dx, so we can factor that dy dx out. So we can say that dy dx times 3y squared plus 2y minus 5 equals 2x. Now we're one step away here. If we want to solve for dy dx, figure out what dy dx is all by itself. All we need to do is realize that it's dy dx times this, so we can take 2x and divide 3y squared plus 2y minus 5, and there's our answer. Okay. So let's keep this going with the next set of problems and see what we need to do. All right, so we start off with x cubed. X cubed is 3x squared. Don't need to put a dy dx because it's an x, it matches. All right, now we have minus x times y. We have to do the product rule because it's x times y. All right, so the derivative of negative x is -1. We'll leave the y alone. Next, we'll leave the negative x alone, take the derivative of y, which is 1, dy dx. Okay, so we messed with the y, we got to put dy dx. All right, then we got plus y squared, which is 2y, but we got to put a dy dx. And then we got the derivative of 7, which is 0. Okay, so anything that has a dy dx is going to stay on this side. Anything that doesn't moves on over. So let's see, this would be a negative x dy dx plus 2y dy dx. And then equals, we'll move this over. I'll put this in positive. I'll put the positive y first and then minus 3x squared. Okay, so now we need to factor out our dy dx. So dy dx is equal to, if we factor that out, that would be, or not dy dx equals, I'm already thinking ahead. We need to factor out, so it'd be a negative x plus 2y, and then equals y minus 3x squared. All we did was took the y dx from both of those terms. And then lastly, we need to divide to solve, so dy dx is equal to what we have on the right side, y minus 3x squared, divided by what we have here, negative x plus 2y. And there's our answer. Okay, I believe we got a couple more problems. Yep, we'll do 2 more and then we'll worry about the slopes tomorrow. All right, ooh-wee, this looks like it's gonna be fun. So if you notice this one here, we actually have chain rule because this is xy to the 1/2 power. So it's something to the 1/2 power. And then we have the product rule inside of there. So let's have some fun. Let's take the derivative of this one right away. So the derivative of something to the 1/2 power will be 1/2 of that something to the negative 1/2 power. And then we got to times by the derivative of the inside. The derivative of the inside, we got to do the product rule because it's x times y. All right, the derivative of x is, here is 1. We'll leave the y alone. Plus, now we'll leave the x alone, take the derivative of y, which is dy dx. Okay, is equal to, okay, now x squared y, we got to do the product rule of. Derivative of x squared is 2x. We'll leave the y alone. Plus, now we'll leave the x squared alone, take the derivative of y, which is also a dy dx. And the derivative of 1 is 0. Okay, what we need to do now maybe is to, let's go ahead and distribute this to both of those terms here. Now, really, this is 1 over 2 radical x, and I'm going to times that by y. So this would be y over 2 radical xy plus x over 2 radical xy dy dx is equal to 2xy plus x squared dy dx. Okay, so let's move anything that has a dy dx over to this side, and we'll take this one and move it over there. So we would get, okay, x over 2 radical xy dy dx minus x squared, we'll move this x squared over dy dx, is equal to, we got 2xy here, and then we'll minus the y over 2 radical xy. Okay, so what we can do now is, if you think about it, this is where we can start combining steps. We're going to factor this out and then divide by what's left over. So really dy dx is going to equal what we have on the right side, 2xy minus y over 2 radical xy. And then we're going to divide it by what we factor out here, x over 2 radical xy minus x squared. Now, I'm sure this can simplify quite a bit, but that's good enough there. All right, I'm going to clear this off. Feel free to pause the video and watch it again if you have any questions, but let's do this last problem here. All right, so sine of x, the derivative of sine of x is cosine of x, and that was an x, so we don't do anything special. All right, then plus 2 cosine of 2y. All right, so we need to do the chain rule. All right, derivative of 2 cosine of something is negative 2 sine of that something. But then we need to times by the derivative of the inside. The derivative of the inside derivative of 2y is 2 dy dx. And then equals derivative of 1 is 0. All right, so let's see here. We're going to move the cosine over to this other side because it doesn't have a dy dx. And then let's simplify this. Negative 2 times this 2 here. We get a negative 4 sine of 2y dy dx. And then equals, we'll minus the cosine over, minus cosine of x. All right, so then we need to just divide by this here. If I divide a negative cosine by a negative 4 sine, that just becomes positive. So dy dx is equal to positive cosine over 4 sine of 2y. And there we go. So take some time today, do the practice problems that we have for your homework. Make sure you kind of understand. So we're going to keep this real simple. If it, if it's a y or anything else, just put a dy dx. All right, guys, have some fun with this. If you have any questions, make sure you ask. If not, I will see you guys next time.